All right, let's look at section 4.2. Section 4.2 has two topics in it. It's Rolle's theorem and the mean value theorem. These are fairly important conceptual ideas for calculus, but we're only going to do one example of each. It's mainly the idea that you need. Rolle's theorem says this. Suppose you got a function that has 2 points that have the same y coordinate. So here and here. So any function that has 2 points with the same y coordinate, as long as it's continuous and differentiable between those points, then somewhere between them the tangent is going to be horizontal. So I'm going to draw in just any function I want as long as it's continuous and differentiable between those 2 points. And when I draw that in, you can look at it and see right here and right here, these are both places where the tangent is horizontal. Now, it looks like we got some more of them over here too, but Rolle's theorem just says that somewhere in between those two, we have to have horizontal tangents. Another way you can think of this is, no matter how, I can draw any function I want to through here, no matter how I do it, as long as it connects those 2 points and it's continuous and differentiable in between, we're forced to have a horizontal tangent. I mean, it's going to happen up here on the top, or if I drew a really squiggly function like this, it's going to have a bunch of them. But as long as you make it continuous and differentiable in between, you're guaranteed, or you're forced to have at least one. So let's look at the statement of this a little more formally. It says, if f is a function that satisfies these 3 conditions, continuous on AB, differentiable on AB, and f of a equals f of b. That's the part that says the y coordinates are the same for those 2 points. Then there's at least one number c in between a and b for which f prime of c equals 0. And let's do an example of this. Show that the function f of x equals x cubed minus 5x squared minus 8x plus 10 satisfies the conditions of Rolle's theorem, and then on the interval from -2 to 6. And then after we do that, we want to find all the values of c that satisfy the conclusion. All right, so 1 and 2 up here. Since f of x is a polynomial, it is continuous and differentiable everywhere. So certainly on the interval from -2 to 6. That's all we have to do for that. I'm not going to ask you to do anything more complicated than that. And then we have to verify that f of a equals f of b. Well, if you plug in f of -2, let's see, a equals -2, b equals 6. If you plug those in, -2 is going to give you, well, I'll just go ahead and tell you, both these give you -2 for the y value. I don't want to spend time working that out. So that right there takes care of condition 3. All right, so this satisfies Rolle's theorem. That means we're guaranteed that between -2 and 6, we're going to have at least one place with the horizontal tangent. So let's take the derivative and find it. So f prime of x is going to be 3x squared minus 10x minus 8. And so what this is saying is somewhere in between here, or somewhere in between -2 and 6, we can find an x value that makes this 0. So let's see, can we solve this? Well, we can certainly solve it. The question is, can we factor it? Let's see, the 3x squared has to split into 3x times x. The 8, if we split it into 4 times 2, that'll give us 12x and 2x. And we can put that together to make the 10x. make this minus 4, so therefore we get negative 12x plus 2x gives me negative 10x. So this gives me two solutions. This gives me x is negative 2/3, and the other one gives me x equals 4. And I'm calling these x, but maybe I should call them c because that's what Rolle's theorem calls them. That's my two values of c. Now let's look at this on Desmos just to verify it. All right. This is a Desmos sheet that I put together that graphs tangent lines. So let's see, we've got f of x is x cubed minus 5x squared minus 8x plus 10. All right. So here, if we go from, let's see, I want to adjust the, let's see if we zoom in. Let's plot a couple of points here. 2 comma, not 2, negative 2 comma f of negative 2. And then 6 comma f of 6. All right, so those are the 2 points that we wanted. Let's label them. So we've got those 2 points, and they have the same y coordinate. And this is saying at 2 places in between, there's a tangent, there's a horizontal tangent. One of those is up here at, sure enough, negative 2/3. And yeah, if I could stop it exactly there, it would be a horizontal tangent. And then down here at the bottom, here at 4, negative 38. I can stop on that one. So yeah, so we've got the 2 numbers there that satisfy Rolle's theorem. All right, that'll do it for this video. Next video, we'll talk about the mean value theorem.